What's up, YouTube? Today I'm going to have a look at the 2024 January question 5. I like this one, and there tends to be a bit of a pattern with some of the buildings towards the end of these past papers in that they're a bit smaller. And I think along with that, they try and make the question a bit more challenging, but I still think it's worth it. Personally, comment if you disagree, but I feel like it would be easier to tackle a smaller building with less floors, because it's essentially just less floor plans and sections that you have to draw, so you might be able to save a bit more time in the process. That's my personal preference. So let's take a look at this community building. Before we go down and read, we can see we've got a canopy for the upper ground with the overhangs. So we're already thinking about cantilevers in our roof framing plan. We've got a core here that we can use for lateral stability. We've got this varying ground profile and some adjacent assets being a highway and a railway line. So that makes me think of using retaining walls so that we don't sort of disturb the ground profile or foundations of those existing assets. And the fact, we do have that varying ground profile where the lower ground floor seems to be somewhat like built into that existing ground surface level. And so the floor plans. So let's go have a look at the client requirements. I won't go and read this all out because you can read it faster than I can speak it out, but I will highlight what I thought was significant. If I've missed anything, again, just chuck it in the comments. So they've told you the minimum internal clear height of 3 meters and a floor to floor height of 4 meters. So that gives us 1 meter to play with our structural depth. And also they've flagged here that we need to consider the services integration. So don't ignore that. If you do use that full meter, it could be, say, an open space truss, and you could just have a comment saying, allow services through in between the diagonal and webs of your truss members. Or if you are using a plate girder that's, say, a full meter deep, you would need to show that you've got some penetrations in the middle of your web there to reticulate services. Or if you don't go that deep, you could say, if you're using 500 meter deep section, you've got another 500 meters to play underneath that to reticulate your services within that 1 meter zone. Now, the upper ground floor, you've got no internal columns, so note that. And they tell you it's a glazed facade, so that essentially means, no bracing along that facade is permitted, so that's going to influence the lateral stability system that you choose. And then they've told you here that the lower ground floor requires provision for 4 teaching space classrooms. So interestingly, as we just saw before, they don't actually show the layout of those 4 classrooms, which is seems to me somewhat unusual. Usually they actually, on most architectural plans, I'll show you the classroom. So I guess that's for us to sort of interpret a little bit. So columns are permitted here, and they've told you the minimum spacing of 6 meters. So we'll make sure we'll comply with that. The upper ground floors incorporate a slim profile, not really sure what that is. And we got that projecting canopy, no supporting columns below. We already captured that, that's a cantilever. And then they tell you here that the lower ground floor roof structure is used as an external garden terrace. And that's also reflected in these imposed loadings here. So you're going to be using different span to depth ratios between your upper ground floor roof compared to your lower ground floor roof, because the loadings are different. And the loadings are different because the lower ground floor roof is used as a garden terrace. So it's essentially like a floor beam is what the span to depth ratio you'll be using here, as opposed to the upper ground roof where, it's only taking, 0.6 kPa. And then what we saw in the layout earlier is the boundaries and those the highway to the south and that railway line to the north. So if we go down and look at the existing site conditions, the ground profile, so that first 1 meter's made ground, to me, they don't give you any engineering profiles, so that essentially means you need to suspend over it and get down to the better stuff, or you need to excavate it and replace it with engineered fill. Then we've got some cohesive soil, so the C is the cohesion. So to get an approximate bearing capacity, we times it by 2. Go back and look at my foundation video for a bit of a recap there. But yeah, essentially, so that first meter where the soft clay is, see the cohesion's 10 kPa, so times it by 2, 20 kPa. That's pretty small for bearing capacity. So that's why you'll see when we go for a second and look at my layout that I've gone down to the stiff clay where the cohesion's 50 kPa. So we get an approximate allowable bearing capacity of 100, which is a bit better to work with. So for this particular video, I'm going to try and keep it short and punchy to the point. I'm just going to, for section 1, show you my first concept. I'll come back later and show on another video what I'm thinking about for a second concept and critically sort of evaluate the two. So if we come in here, here's the layout that I'm proposing to show just for one option. I'll put a description, some roof framing plan, a foundation plan, a section to really capture that varying ground profile. And then similar to previous videos, where I sort of analyze my concepts, I show my understanding and sort of draw the bending moment diagrams and the load paths for the gravity load path as well as the lateral load path. So if we just have a look at the roof framing plan, I'll turn on my description. And yeah, I really like to sort of box out and say the lateral stability system. I think that's critical. And yeah, I kind of like pull it apart from the description. So here I'm using reinforced concrete shear walls at the core. So there's sort of like a U shape here. My upper ground floor roof framing plan is essentially, just some steel roof framing plan with these cantilevers to capture that canopy that sort of has that 2 meter overhang. The lower ground floor, I'm using a composite floor system with steel composite beams. I'm just using typical span to depth ratios. So these beams here are spanning, so I don't have the, I should have put the dimensions here, but these beams here are spanning 6 meters. I've got the columns through the middle. So my intention is essentially that 6 meters is our center-to-center minimum distance for the columns that we read in the architectural requirements. And if I just draw this square here, 1, 2, 3, 4, they're essentially the 4 classroom spaces that I've allowed for these classrooms because I haven't drawn them on the plan. And then this would be the internal sort of wall between that divides some of those classrooms where I'm hiding the columns. My secondary beams are spaced at 3 meter centers. I've got a 150 thick composite slab that'll just be like a Bondex spanning between my secondary beams. The secondary beams landing on my 300 UB primary beams. It's all composite formwork. And these beams are deeper than and they're composite as well, so you will get a lot more sort of stiffness and bending capacity compared to our roof beams, which are just non-composite 250 UBs. And that is intentional because the lower ground floor is essentially used as floor, or the lower ground floor's roof is at garden terrace, which has about 7 kPa compared to the roof of the upper ground, which is just a it's just a lightweight roof. So my foundation plan will turn that on. I've got this 250 thick retaining wall that goes around sort of 3 sides here, and that is to capture that varying ground profile level. And I've also used it as a mechanism to not sort of disturb the adjacent highway that's just within 3 meters here. Then I've got my core wall that sort of extends above the lower ground floor, and that's used as my lateral stability system, which is what I mentioned in the description, and we'll see that when I sketch the lateral loads and the lateral stability system here. So here I'm just showing, essentially the foundations, and it's, got a 200 slab on grade. We've got 2 meter square pad footings founded on that stiff clay, which gives us about 100 kPa, and I've sized that just based off the tributary area of one of the columns here. So it's 6 meters by 9 meters, so that's 54 meters squared with about 7 kPa, and then compare that to the bearing capacity in our stiff clay, which we just said had about 100 kPa. And I've used 2 meter square pad there. Might just double check that calc. I can't remember if I tried it with 5 kPa or 7 kPa. I've extended the reinforced concrete wall sort of 3 meters into the ground here, and that's to provide, you can kind of see if I pulled this up a bit, you would have this retaining wall with all this earth pressure here, but no passive earth pressure to resist it from essentially just sliding across the page. So I've sort of extended this 3 meter deep shear key just to provide some passive earth pressure to resist our sort of retaining wall just from sliding across. Here's the core wall here, and 200 slab on grade, and we've got our pads for our columns that are just sitting on that stiff to very stiff clay. And I've sketched out each of the soil materials that we saw in the description, and I've also replaced that engineered fill replace the topsoil with some engineered fill, as that's what my slab on grade is just going to be bearing on. So if we come over and just look at what I've done for the section, you can see here, so engineered fill is what's sitting underneath my slab on grade. We've got our pads on that stiff clay. I've just picked up here, if I come to my plan, this central beam here kind of runs into the middle of my core, so I'll have a beam. So this is the roof of the upper ground versus the roof of the lower ground. So this beam doesn't actually meet that beam. They're on 2 different planes. So I show that in that section. I've got another beam, a 300 UB, that will just span between the 2 reinforced concrete core walls that are somewhat U-shaped. So it's sort of below this beam here. And that's what's going to pick up the end of this primary beam here. And then there are pads. So if we come and just sketch the gravity load system, it's pretty simple, but I think that's all we need to do in this concept phase. In section 1, it's really just demonstrate our understanding of the concept that we just put together. I like to use color. Here you can just see, I've just drawn some, a UDL. I've got my composite beams, which are just simply supported, spanning between some reinforced concrete columns, loads coming down into my pad footings into that stiff clay, and we've got the cantilevering canopy out here, obviously picking up some moments, coming back into our core wall here. That's all pretty simple, and then I've just illustrated the lateral load path, a couple of arrows coming to the left. We've got our retaining wall, the passive earth resistance. I could have drawn a triangular load distribution to just demonstrate that engaging the passive soil pressure to resist some of these lateral loads, and the core wall, which will acting as our lateral stability mechanism, that moment at the base being transferred to again a varying soil pressure profile. So one thing that I haven't done here that I probably would like to do just for this section is just demonstrate. I would have shown, if I've got, say, this floor system here, I've got a 150 composite slab sitting on top of 300 UB, so it's 450, call it 500. I just show that I've allowed for that 500 space to articulate the services that we said where there was a client requirement. So that's just one thing that's sort of like missing from this scheme here, in my opinion. Let me know if you've got any comments on this, if you yeah, if there's something that you disagree with, you got questions, just drop it in the comments. I'll get back to you. And yeah, I'm obviously missing option 2, which I'll come back on another video. Thanks.